what'll happen with formulas, I put them on a sheet, and it will look like this. Yesterday, you guys had formulas of the hyperbolas that looked like it was x squared over a squared minus y squared over b squared equals 1. And then you had y squared over a squared minus x squared over b squared equals 1. And I would just draw next to this, hey, this one goes left and right, and this one goes up and down. That's what the formulas will look like. Okay? Because as we get into when we start talking about ones that when we start shifting, there's a lot more math going on. So that way you can worry about using the calculators then, because those will be the same basic images that the calculators have. Okay? Same thing with ellipses, the x squared, y squared ones. I drew the picture of what they would look like. I even drew a picture of a circle for you. You're welcome. You know, things like that. You're looking like I'm crazy because I drew a circle. And then the last one was the parabolas. So it shows you if it's up or if it's right. You know, I just drew it like that. I didn't draw all of them. When you go through the quiz stuff, then things you got to remember. What doesn't change? What are these values of A? Always. Distance from something to something. That something to something is kind of important. What was the something to something? Center to vertex. A is always distance from center to vertex. B is always the what? Center to co-vertex. And then C, okay. Now there were two different formulas for figuring out, finding the foci, the C value. When do you use what? When do you use what? If you have a hyperbola, what's the formula for C? Okay. So here's when C squared is A squared plus B squared. And what was the way I was showing you guys the shortcut to remember that by? Yeah. If a hyperbola is subtraction, C is plus. And ellipse is addition, which means C is minus. Just remember it's going to be the opposite. Okay? Also, remember that no matter what, every vertex looks towards a focus. It always looks towards it. So a lot of times when we were drawing things out, if we were given vertices, in a foci, if it wasn't told to you what it was, if you were able to plot it, seeing if it was looking away or looking inward, you should be able to decipher whether or not it's going to be a hyperbola or an ellipse. Okay? When you had the, what do you call them? Parabolas, was a little bit different. We'll get through all that as well. I just want to remind you of those. What was the other thing we had to worry about there? Oh, directrix. So let's just start with parabolas. And what I did was I just kind of cut and pasted a bunch of problems together. This was I was thinking of and I kind of cut and pasted together a whole bunch of things. And I just want to kind of run through again what everything looks like. Okay? So parabolas, there were two equations for parabolas. We had the x squared parabola and we had a y squared parabola. They both equaled this 4p times something. And then it was just a matter of telling whether or not what direction it was going. You guys have all dealt with x squared parabolas before. You guys know what direction those go. What direction x squared parabolas always go? Up or down, okay? Which by process of elimination means y squared parabolas have to go left and right. So on the formula sheet, I just did this, and I think I did this. I don't remember if I wrote up or down. I don't remember if I did or not. Might have. Yeah. Bless you. Now, when you go through the parabola stuff, remember, everything is still centered at the origin. What does this value of p represent? Well, you're right with the focus thing. It's the distance from the center to the focus. Yeah. Actually, technically it's a vertex. So vertex to focus, and then the opposite of p is the distance from the vertex to the directrix. Now the directrix. The directrix was a line. Now, if you're x squared up like a cup or down like a frown parabola, what kind of a line, x equals a number or y equals a number, would the directrix be? It'd be horizontal, correct, but what's the equation of a horizontal line then? Y equals good. So your directrix for an x squared is always going to be y equals a number. Therefore, by process of elimination, the y squared have a directrix that is x equals a number. Okay. So if I'm looking at these, and let's see, looks like I went, one side has hyperbola, then below that is parabola, the other side is ellipse, and then circles, I think? Yeah. So if I'm looking at the side that has hyperbola on the top, parabola on the bottom, I'm going to talk about a parabola. Figure that would make sense. So if we want to walk through like a whole setup of what in the world to do, let's look at, I don't know, let's look at number, I might as well just do number 1. Okay. I know you're feverishly right now, so I'm going to go with that. Okay. If I look at number 1, it says 8x squared equals y. If I have 8x squared equals y, well, I need to get into that format, the generic format of x squared equals 4py. What do? Divide the 8, good. So I like to write and keep things in terms of fractions, so I'm going to have x squared equals 1/8 y. You okay with that? Now, in order to identify all the parts then, what do I do with that 1/8? What do I have to do? Yeah, set it, you're right, set it equal to 4p to figure out what the p value is. So I know that 1/8 is playing the role of the 4p. So you would divide by the 4 and you get 1/28, I believe. 36, yeah, 30 seconds, I was thinking 7. So that p value tells you that your distance from your center to your focus is 1/32. Whatever. I mean, it's cheesy. I get it. But could you fudge it enough on a graph if you had to? Yeah. All right. Now, is this one going to go open upward or downward? Up. It's upward. It's positive. Okay. So I know that our vertex is at the origin. And if I say this is about 1 here, would this be about 1/32-ish? No. All right. And then my curve, something like that. Then what's the last thing I'd have to put in? The directrix. And the equation of the directrix for this one would just be y equals -1/32. It doesn't have to be perfect, obviously, because it's such a small fractional amount, you're not going to be grabbing that one. nicely, as long as things are identified, labeled, done right, you're fine. Okay? Plus, you don't know how wide or how small that curve is going to open itself up. But that's generally what you'd have to do. Write the standard form of equation of a parabola with a given focus and vertex at 0, 0. So if I look down now at number 11, I have a vertex at 0, 0, and I have a focus at -12 and 0. So in order for us to figure this out, we got to know which way it's opening. Bless you. Which way is this opening? Left. It's opening left. So is this a, excuse me, is this an x squared or a y squared parabola? It's a y squared. Very good. This is going to be a y squared parabola. And your p-value is the distance from the center to the focus. How far is that? 12. So, but since it opened to the left, is this going to be a positive or negative? So our p-value here, so you get y squared is -48x. They're real quick when you start thinking about it. The idea is that you're opening towards your focus. Okay. What's the difference between opening toward when you have a focus or a directrix? If you're given a directrix, which way do you open? The opposite way. Very good. Okay, because the directrix is always located behind your vertex, no matter what. So if you look at number 20, number 20, you have a directrix at y equals 2. So if I have a directrix at y equals 2, well, graphically, that just means that y equals 2, is that a horizontal or vertical line? Oh, horizontal. It's a horizontal line through 2, which means what way does this have to open? Down. It's got to open downward. So is this going to be an x squared or a y squared parabola? It's an x squared. Is it going to be positive or negative? It's going to be negative because it's opening down. Okay. So if you're, excuse me, you have an x squared equals 4 py. Well, our p-value here is what? It'll be -2. Very good. So you wind up with x squared equals -8y. Okay. That was pretty easy. Nothing too crazy. It's just the idea that everything kind of it stems from just remembering that this is such a visual thing, guys. If you're able to plot and look at a couple of things here and there, it just makes everything super easy. Right? It makes everything super easy. After we did parabolas, we did ellipses, right? So we look at the page after. If you flip it over, the top of the page is the ellipse. And in the ellipse, there's two styles. There's graph, label everything, and then write equations and stuff. So if we look at one, let's do number 6. Okay, let's do number 6 with the ellipse. We have 169 x squared plus y squared equals 169. So the first thing we have to do is what? Good. We divide everything by 169. Bless you. So we divide everything out by 169. When we do that, you get x squared over 1 plus y squared over 169 equals 1. Now, in the ellipse, a squared mattered. In the hyperbola, it didn't. Which one of those numbers is playing the role of a squared? 169, good. Remember, in the ellipse, the larger of the two numbers in the denominator will always be the a squared. Okay? So if the a squared is underneath the y squared term, which direction is this being stretched? Up and down. It has to be stretched up and down. So we know that this one's got to be stretched up and down. Then we start listing our parts. A squared, 169. B squared, 1. C squared is going to be 169, subtract 1. So what's your value then of A? 13. So we write it as your A value is going to be plus or minus 13. B plus or minus 1. C plus or minus the square root of 168. Now we have to remember how to simplify square roots. When we simplify square roots, we're looking for the largest perfect square that goes into a number. Right off the bat, I'm seeing this as a 4. I see 4 goes into it, but if I do that, let's see what happens. If I divide 168 by 4, what do we get? 42. So I know that this is going to be 2 root 42. Then I have to think, is there another number that goes into 42? What? 68. Who do we appreciate? I don't know. Well, 6 isn't a perfect square. So think about it again. Does 4 go into that cleanly? No. Does 9? No. Does 16? No. Then you got 25. Then you're at 36. So you're done. Okay. That's the idea. You try to go until you can't go any further. Okay. So then that's my plus minus for my C value. Now, when we graph that, we're going to guesstimate close-ish. Remember that? Isn't the square root of 168 really close to the square root of 169? Bless you. So it's like 12.9-ish. Bless you. So now we just start plotting. Okay? When we plot these things, as you guys remember, hopefully, our center is at the origin, so your center at 0, 0. Vertex. Center to vertex is your A value. So you go up and down 13. Your co-vertex is left and right 1. And we start listing our parts. So vertex, 0, 13, 0, negative 13, co-vertex, 1, negative 1, 0, and then your foci. Your foci are going to go up and down again, so is that going to be an x coordinate or a y coordinate? Good. 0, 2 root 42, 0, negative 2 root 42. Here-ish and here-ish. Draw your really squished together lemon head or really badly drawn something. Canine tooth, I guess. I don't know. Blah, blah, blah. Yeah. It's like, why such the long face? Sake of course. Hey, come February, you're only going to hope that Miss Yule is as funny as me. Thanks for your support. I appreciate that. And that's all the parts for this one. Are there asymptotes with hyperbolas? I'm sorry, with ellipses? Yes, sir. Yeah, asymptotes. Remember the slant asymptotes you guys found yesterday? No, we're getting to them again. Yeah, the dotted diagonal lines. Yeah, yeah, those were called slant asymptotes. All right. Now the other part of the ellipse stuff was basically writing the equation given information. So if you look at one like number 18, you have a covertex and a focus. I'm still with the ellipses on the top up here. I'm still working with the ellipses. So if I look at that one, you have a covertex at 0 and 2, and a focus when we do these things, it is so important to draw, so you get a visualization of what it's supposed to look like. So if your covertex is at 0 and 2, oh, did I forget to put? If your covertex is at 0 and 2, but you're the only one that caught that one. I plotted it on the x value, and then I rotated the graph because I made a mistake and I just flipped it. Nobody else realized it was going on. You saw nothing. And then your focus is going left to the left. Oh, 4 root 2. 4 root 2, we got to figure out what a decimal equivalent of that is so we get an idea of where to plot it. So when you square it, I want to figure out what 4 root 2 was unsimplified. So when you square that, yep, 16 and 2, you get 32. So the square root of 32, it's more than 5, but less than 6. So you get an idea of which way things are moving. So it's here-ish. So which way was this one stretched? It was stretched left and right, okay? This one's stretched left and right. So we know it's going to have to do something like this. So my a squared value is going to be underneath which variable? X, good. So we have the formula then, x squared over a squared plus y squared over b squared is 1. Well, we know b. That's easy to find. B was the distance from the center to the covertex. So if b is 2, what's b squared? Good. Also, since we know that our c value was the square root of 32, what's c squared? 2. Okay. Now, excuse me. In order to figure out c squared, is it a squared plus b squared, or is it a squared minus b squared? Minus. So we know that we have to do something squared minus 4 is 32. What's that something squared? 36. So that means our a squared value is 36. Our b squared value was 4, and it equals 1. Yes, ma'am. Correct. What changes is the a and b. It's the bigger of the two is always the a squared. It's always that. Pretty straightforward, right? Yes, ma'am. What's that? Yes. Write the equation of the ellipse, or it says write the equation of the conic section with the given information. Is what I've been wording it as, because with a focus and a covertex, you'd have to be told if it's an ellipse or a hyperbola. But if I give you a focus and a vertex, I don't have to tell you what it is, because vertices always open to the focus. So if the focus is past Where the vertex is, it's hyperbola, or if it's inside it, it's an ellipse. Okay. Yeah. All right. And then lastly, when we get back to where we were at, then we went to circles. Circles are pretty easy. I think the trickiest part was when you had to do the slope of or write the equation of the tangent line through a point. You vaguely remember that? Yeah, you use the Pythagorean theorem, then you do all that. So let's just roll through one of those real quick. Write the equation of the circle and the point on the, or sorry, the equation of the circle and a point on the circle is given. Write the equation of the line that is tangent to the circle at that point. So if I'm looking at number 18, we have the equation x squared plus y squared is 50, and we want to be tangent at point -7 and 1. Right. We're basically doing this. There's the point that's on the circle, and I want to write the equation of the line that is tangent to that circle. When you are tangent to the circle, how many times do you touch it? Once. And what are you to the radius then? Perpendicular. Very good. So what we need to do is we need to figure out what the slope is of that radius. So that radius, rise over run, it went up 1, and it went to the left 7. So what's that slope? Is it positive or negative? Negative. So the slope here is -1 over 7. 1 over -7 means the same thing. Right? Means the same thing. Now, if you're perpendicular to it, what are your slopes? 7. Yeah, it's the opposite reciprocal. Change the sign, flip the fraction. Easiest thing to remember. So the perpendicular slope would be 7. And through what ordered pair do you need to write the equation? And this is where it goes back to writing the equations of the lines given a point and slope. Yep, you use point slope. And fill in the blanks. So you get y minus 1 is 7 times x plus 7. 7x plus 49. And then we get 7x plus 50, I believe. Yes, sir.
I was wondering, but you can just skip it all by flipping the x or the value of the x in the parentheses and then adding that's it.
Yeah, you could do that. Absolutely. The only reason why I'm going long form is because as soon as you start shifting everything, you have to do the steps. So I'm just showing the steps now, so that way when you can't use those shortcuts, you'll remember why we did it that way. That's all. But yeah, you're right. When they're centered at the origin, it's really quick. You flip it and you're done. Yes, ma'am. Yep. The equation of the tangent line, write the equation of the line that is tangent to the circle through a specific point. So since our circles are centered at the origin, it's once they start moving, they get a little crazy-ish. Okay? Again, not terrible, was it? Hopefully. And then lastly was the hyperbola stuff that you guys did last night. And this shouldn't be crazy. We'll walk through one so we can see how all of it kind of melts together. Let's do number 2. We'll go through the process, write everything out, do the slant asymptotes, the diagonal lines that you found, all that fun stuff. What's the first step? That's 4, right? Yeah. Which way is this going? Up and down or left and right?
Up and down.
Which is it? Excuse me. So what's your a value then? Yeah, remember the a squared value is always what comes first. A squared value is always what comes first. For hyperbolas, it's always what comes first. Hyperbolas are the weird ones. It's what comes first when you work through those. What is it? When you have the tricky thing that you might come across is what would happen. I don't know if we did one like this, but what would change if this was a negative 64 on the one side? What would you have to divide by? You'd have to divide by negative 64. And then this becomes negative, this becomes positive, which means what do you have to do? You have to flip them. It'd be x squared over 4 minus y squared over 64. That's about as crazy as you can get with a hyperbola if you have to divide up by a negative. Then when you rewrite, you just have to put the subtractions second. That's really as crazy as this angle. So let's see here. We know we got to go this way and this way. A squared is 64. B squared, 4. C squared then will have to be 68. We just add them together. You okay with that? Start filling in the blanks then. A plus or minus 8. B plus or minus 2. C plus or minus root 68. I think 4, I was just going to say, I think 4 goes into that. And if 4, because 4 gives you, like we were just saying, 2 root 17. Everybody's like, ugh. What's that? Yep. Then remember the reason being, because if that's subtraction, the c squared is plus. When the ellipse was addition, the c squared was minus. That's how you're able to get the, because if you look at it, isn't 68 bigger than 64? That way the focus is further away from the vertex. That's how it gets there. Asymptotes galore. And then we have, it's up here-ish, here. Remember, hug your asymptote, go through the vertex, hug your asymptote. Hug your asymptote, go through the vertex, hug your asymptote. And then lastly, we have, obviously we have a list, but to write the equations of the slants, yeah, we're just using slopes here, guys, because you're going through the origin. You don't have to worry about really anything here. Next week we'll worry about it, and you guys will get mad at me. I'll be fine with that. I'm gonna break the chair even more than it is. I went up 8 over 2. What's my slope? 4. I also went down 8 over 2. So my two equations. This only works when we're centered at the origin to be able to do this. We have y equals plus or minus 4x. You can write them separately, or you can write them together like that. Those are the equations of the slant asymptotes. 4x and negative 4x. Like I've said, a lot of times with these things, I will make a, when I have you guys graph stuff, I'll write out what's the center, what's the vertex, what's the co-vertex, what's the focus, and then the equation of the asymptotes if needed. Correct. Because a lot of times as we get going into these things, I don't want to tell you what something is when you have a conic written in standard form. you have to figure out what it is, and then if I tell you you need an asymptote, you know you're going to have a hyperbola. So that's why I write in that little thing, if needed. Right. Correct. Correct. And usually what I do with the equations, they tend to start like that one was up there, where it was like x squared minus 16x over 64. I usually write them like that to start with because you have to do some work to get to it. Because honestly, the reason I'm doing that now is so that way when we get to when we get to stuff like this, you'll know what to do. When it starts looking all crazy and all that. Lots and lots and lots of complete the square. If you weren't any good at completing the square before, you're gonna get really good at it. F of b squared at both sides. But your first term always has to be 1. It's a little bit of math. It's not bad. It's a practical. That's why this is a practical application for the complete square stuff. Other than that, I mean, when we get into writing the equations, again, it's just identifying. Remember that your A value is always centered to vertex, B is centered to co-vertex, C is always centered to focus, and then remembering which one's which as far as your A squared, B squared stuff is concerned. And you have the formulas. You know that's just the opposite sign for the A squared, B squared. Okay. Any other lingering styles of questions or anything besides you? Anybody? Anybody help? Help? Yeah. No, I gotta help. If there's a number, then you have to divide it out. Then you probably not have a circle. Right. Because the circle, that's a good question. Circles, the reason why they're circles is because their A and B values are the same. That's why that works. Now, what do you have? And that's why whatever you do, if you always want to plot a rough sketch. So if you know if you wind up with foci at 1, 2, at 3 and -3, oops. And it tells you have a vertex at 5 and -5, you know that it's got to go this way. Because it will always open, the vertex always looks at its focus. That's why you only need to have one set of those. Other than that, I mean, honestly, I don't really see this being horrible. I hope. Because then on Thursday, we'll just hit you over the head with all the shift and stuff. You're going to go, oh. Yeah, but remember the proofs that we start out with from geometry. So you guys will have fun with trigonometric proofs. Yeah. Oh yeah. But it's not like a 2-column proof. It's a lot of simplify, verify. That's what you guys did last year. Yeah, you'll do stuff like this. Sine squared of A times the quantity cosecant squared plus secant squared equals secant squared. No. Let's see, this is 1 plus couple of steps. That's the types of proof that we do second semester in trade. It's just simplify, verify, trigonometric identities. Oh, it's not a two-column proof. And there's only 1, 2, 3, 9, only 9 different identities. Oh, I think there's only 9 identities. So you guys, you say that you're gonna be happy about it.